Continuity. Because you shouldn't have classes. Okay, so here we are on Objective 93, and it's a good day for 93 because it's Monday, and it's a new chapter. So what we're looking at is imaginary and complex numbers. Now, earlier in the year, we did things where we classified numbers, and we said, hey, everything that you've ever known is real. Whether they're rational or irrational.
You can't just go throwing imaginary numbers in real math.
Well, all of a sudden you've gone to a point in Algebra 2 where now it's going to be imaginary.
Just imagine that it's there.
Yeah. So this is the point. We've talked about everything you've ever known up to this point in your life as far as numbers go have been real numbers. But not everything is real. This is where we come up with imaginary numbers. Now, this concept sounds like, okay, now this must be ridiculously hard, because now math was hard enough when we thought it was real math, and now it's imaginary. But if you'll follow along, it's actually not that hard of a concept. Now, here's where they come from. So imaginary numbers have a place that they come from. They come from what is impossible square roots. So to fully understand this concept, we need to recall what we've learned about square roots in the past. So we're going to look at square root of 9. When we evaluate a square root, it looks like, you could just throw square root of 9 in the calculator and find out it's 3. But when we evaluate a square root, what a square root looks like, we must ask ourselves, what number, so square root of 9 means what number, if you multiplied it by itself, would give you 9. So you think, okay, wait, 2 times 2, that's 4, so 3 times 3, that's 9. So it's 3. So square root means what number when multiplied by itself would give you 9. And the answer is 3, because 3 times 3 is 9. All right, so let's look at a few other examples. We know, okay,
6 more to go.
When you have perfect numbers, these are square numbers, they square root perfectly. So if I look at the square root of 25, I'm saying what number, if I multiply by itself, will give me 25? So it's 5. If I looked at the square root of 100, I'm saying what number, if I multiplied by itself, would give me 100? That works out perfectly. It ends up being 10, because 10 times 10 is 100. 144, that's another one that's perfect. Because 144 is 12 times 12. Now, not every number is perfect. These were perfect numbers. If I said square root of 10, there is no whole number that you can multiply by itself to get 10. But when I said 9 and 25 and 100 and 144, you could find one nice integer that if you multiply by itself would give you 144. The problem we're going to see comes from something like this. What we have here is a square root that's not as simple. What is the square root of negative 36? Now the very first thought is, okay, the square root of 36 would be what? Just the square root of 36? 6. Would be 6. So if you have the square root of negative 36, what you might think is, okay, well if it's negative 36, then it's negative 6. But if you multiply negative 6 by itself, negative 6 times negative 6 will never give you a negative 36. Negative 6 times negative 6 is actually positive 36, so that's not it. It doesn't work. You cannot do a negative square root. So if you have the square root symbol and somebody tells you to do a negative number, what is the square root of a negative number? It is virtually impossible. If I said, what's the square root of negative 9? You cannot say, oh, it's 3. Because 3 times 3 is positive 9. You cannot say it's negative 3, because negative 3 times negative 3 is also positive 9. There is no way to win. If you do the square root of a negative number, you cannot find one that if you multiply by itself would give you a positive. Because any number, if you multiply by itself, would be positive. A positive times a positive makes a positive. If you took a negative and multiplied by it, a negative, you get a positive. So it's virtually impossible to do the square root of a negative number. Here's the unfortunate part. Here's the part where Hunter's mind is blown. It's like, okay, that should be the end of the road. Yeah. If it's impossible, it's impossible. True. Done. So we're done. You would think, but we're not. All right, unfortunately, being virtually impossible won't stop us from trying to solve this problem. here's where the imaginary numbers come in. It's virtually impossible. We can't really do the square root of negative 36. So let's go back and look at it. Square root of negative 36. You can't do it. There is no number that multiplied by itself would be negative 36. We know that evaluating the square root is impossible because you can't evaluate a square root of a negative number. However, let's pretend or imagine, because obviously the square root of negative 36 is dumb. Let's pretend or imagine that it's actually positive 36, because that makes sense. The square root of negative 36 doesn't make any sense.
Can't just change it.
Or can we?
No.
All right, so here's how it's going to work. Our original problem up here says we got the square root of negative 36. Now your mind has to go, okay, that's dumb. And I'm going to take Taylor's calculator and show you that if you tried to do this, like if this popped up and you tried to do this on your calculator, and you said, okay, what's the square root of negative 36? Domain error. Your calculator is saying, oh, well that's dumb. You can't have a square root of a negative number.
That's no solution.
No real solution. Here's what we're going to do. Pretend or imagine it's positive. Obviously, square root of negative 36 is dumb. So what we're going to do is pretend. Imagine that it's positive. But if we have to imagine, you have to remind yourself that you imagined. So that's where the I comes in. Add an I next to the square root to remind us that this is virtually impossible, or we're going to pretend, or we're going to imagine. So we put an I to the left. So now it's imaginary square root of 36. It was a square root of negative 36. You can't do that. So we're going to say imagine it was the square root of 36. And the square root of 36 is actually 6. So what we will do is we turn this into 6. And you have I6, or the way that you'll actually see it written is they'll say 6I. Like you put your numbers before your letters if it was X. The answer is 6I. It's 6. I had to imagine it was positive. I had to imagine, and then I came up with 6.
What are you doing?
Okay, so look at a few more examples where you have a negative under a square root. So here you have the square root of negative 4. Now, that's impossible. That's dumb. You can't have the square root of negative 4. So what you're going to do is pretend. Pretend it's not the square root of negative 4. Pretend it's the square root of 4. But what do you add to the left? You add an I. You add the letter I for imaginary. And then the square root of 4 actually does reduce. It's a good square root. Square root of 4 is actually what? 2, because 2 times 2. So what you end up is, the 4, square root of 4 turns into 2. Most likely you're going to see it as 2I. Then we'll look at one. The very next one is a good one that won't reduce. Square root of negative 18. You can't do square roots of a negative, so what do you do?
Imagine.
Imagine that it's positive 18.
Imagine all the numbers.
Now, square root of 18, you cannot, off the top of your head, think of some number that if you multiply by itself gives you 18. So I would say let's check on the calculator what the square root of 18 is. Yeah. If you check on the calculator what the square root of positive 18 is, it's going to say 3 square root of 2. So then that's as much as it's going to reduce. I mean, you could toggle it to 4.24, but let's just leave it as 3 square root of 2. And so what they're going to do is you're going to have I 3 square root of 2. Most likely they'll write it like this though. So circle that one. They're going to say 3i square root of 2. Not saying that these are all wrong. This is what you're going to see. They'll stick the I, always trying to keep it left of the square root, at least most of the time. But be ready. I mean, it could be I times 3 square root of 2, or it could be 3 square root of 2 with an I to the right. I would circle this one because it's kind of already boxed in. Most likely, that's what the answer will look like. But it's 3 square root of 2 with an I in there, because it's imaginary. It's total bull. It's not true. You can't do the square root of a negative, but if we imagine, this is what we'd come up with. Okay, now you're going to try some. There are a couple of these that work out perfect, and a couple just kind of simplify to other square roots. Go ahead and try these. Look on your own. You got square root of negative 49. You got square root of negative 24. Follow the recipe that we just talked about, and work them out on that last page. And then you'll look and see if you did what I did. ignoring your first step. Show the 3 steps. First step, just pretend and put an I. Okay, the first 2 are up there. Hopefully you've got what I've got. The square root of 24 kind of turned into 2 square roots of 6. I would put it here because that's probably where it is, you know, when you're looking at answers.
This teacher was straight up.
Well, I remember to do a class like that. Hit on one.
I didn't hear.
Units. So watch that.
Was this like a quiz or something?
The only class.
It's not
It
a
says name
quiz.
at the bottom, so.
So what name should I put on here?
You should put your name on there. So it's your favorite.
Okay, so here's what you should have had. On the first one, 7i. On the second one, 2i squared root of 6. On the third one, 5i squared root of 5. And on the last one, just 13i. If you have a negative under square roots, that is where imaginary numbers come from.
Sweet. Gravy, dude.
Hey. Alright, and it's not that hard of a concept.
It's not.
It's just totally different. It's a different, changing gears, different stuff than what we've been working on.
Can you give me an
Straight
exercise of
up,
it?
not even.
I'll look and see what you've got, maybe.
Hopefully. At least I need something. I need something.
Uh,
Hey, strong word.